Hey everybody, Mr. Ellinger here, and it's Thursday, day before our sub day when I'll be gone, and I'm just going to record the answers to this in case you're curious to see what the answers are. You should have already done this activity in class with your group. So if you're one of those people who trolls the content library in between classes, please don't look any more further. Go away. It's fine. It's not a test or anything, but you'll get a chance to work on this as a group next class. Okay, so let's go to this, and I'm going to give you the answers to this, and the sub is going to tell you this is here after you guys get a chance to try these problems yourself. All right, let's do it. So here we go. And you can look up these questions. They're online. You just search, AP Statistics, free response 2011, and it'll take you to a link to these problems. All right. And then the other one is 2007, Form B. Okay, here we go. All right, question A. Okay, well, the situation, windmills are doing stuff, and the regression model, yeah. Okay, so what I'm noticing is computer output for the regression analysis for predicting electricity production based on wind velocity. So I know that it's, the electricity against wind velocity. So just, that's what I'm thinking of. This is the situation that's going on here, okay? And one thing that's kind of interesting later on is that they had it's reasonable to use the regression model, to use the line, as long as the wind speeds are between 10 and 40. This is that whole don't extrapolate thing. So just because this predicts how much electricity production you're going to get at 25 miles per hour, it doesn't mean it's going to be any good if it's 200 miles an hour. So that's watching out for that extrapolation thing. I mean, if I run into other things to talk about in here besides just the answers to the questions, then I might throw it in like I just did. Okay, question A. Use computer output to determine the equation of the least squares regression line. Oh, piece of cake. All right, because I've already read it. So A, electricity hat equals, here's the coefficients, 0.137 plus 0.240 times the wind velocity. Again, you can abbreviate as long as the stuff is very clear. That's totally fine. Identify all the variables used in the equation. Now, I kind of already have. I think that is mostly, if people use y and x, they have to say what the y is, what the x is, And so this is, but in case, like thinking about when you're doing a free response, like, can you make this better? Because sometimes might be a little detail that they might take a little off for, or they might not. So just in case, I would say, all right, let's make sure this is electricity production. Did they even give the units for that? Wind velocity in amperes, right? That was in it. Electricity production in amperes. So that's the units for that. And then the wind velocity is miles per hour. So this, I'd say, wind velocity in miles per hour. That's fine. Okay, that's all I had to do for that one. And again, that might not have been required on the rubric, but I'm just making my answer a little bit better because I have enough time, I think. Okay, question B. How much more electricity would the windmill be expected to produce on a day when the wind velocity is 25 than on a day when it's 15? And so the key on this is, if we think about it, it's the slope. So we're going from 15 to 25. So we're going over 10, and we're going up how much? Well, for every plus 1 miles per hour, we expect 0.240 amperes of electricity. What's an ampere? I don't know. I'm just answering the question. You don't need to know what these things are. So therefore, with a linear model here, so it's plus 10 miles per hour is going to be 2.4 amperes. And so now I'll write this statement. And so an increase of plus 10 miles per hour is predicted. Again, emphasizing this is what my model says. It might not be perfect. There might be a little bit of curve to it that they just said linear is good enough, but we're just saying it's predicted to produce an additional 2.4 amperes. Okay, that's just slope. Every 1 you go up 0.24, so every 10 you go up 2.4. It's not a lot of amps. I'm just like checking it out and seeing. Yeah, okay. I mean, I don't really know what amps are, like in terms of what's a lot of amps or what's small amps. It just seemed weird to me, but I could tell it's right based on what I know. What proportion of the variation in electricity production is explained by its linear relationship with wind velocity? That's R squared. So that's 87.3%. And just to write it all out, I don't think I need to. 83% of the variability in electricity production can be explained or is associated by or is related to, can be explained by the linear model with wind velocity. So these windmills, there's a bunch of windmills, and these windmills are producing different amounts of electricity. And how much of that difference is based on the wind velocity, and how much is due to other factors? The fact that some windmills are producing more, some producing less. That variability, 87.3% of that variability is about the wind velocity. Like that's making a huge difference in terms of how much these windmills are producing different amounts of electricity. And maybe there's other factors. Maybe there's like wear and tear. There's one that's kind of breaking down a little bit. There's variability in it, and it's not a perfect predictor, but it's a very good predictor. Okay, that's the answer to the first one. On to part B. Doing good on time. Okay. So adult women giving the height, their own height, and the height of the father. So how well does the height of the father predict the height of the woman? Okay. And so y is her own height, x is that. So you notice how they switched in this one to y hat and x, which is fine, but they define the variables so we know what it is. Draw the least squares regression line on the scatter plot above. They've done this before. It's a little tricky thing because people look at the y-intercept and they think they need the y-intercept. But remember, there's a break right here. And so you can't like go to 35.1, not only because it's not on the graph, but because 35.1 is when x is 0. And so that would be, and this is x equals 50. So that'd be like way over to the left on this one. And so instead, what I'm gonna do is I'm just gonna plug in a couple numbers. So I'm going to plug in 60 into the regression equation. 35.1 plus 0.427 times 60. And I get 60.72. So when the height of the father is 60, we predict the height of the woman to be 60.72. Let's see, these are by twos, so it's about there, a little less than 61. And that's a short father. No offense to any 60-inch fathers. That's 5 feet tall. And so we don't expect the woman to be as short, but we still expect them to be somewhat short. And so we predict them to be around 5 foot, but we actually predict them to be bigger, taller than their father because their father's unusually short. Yeah. All right. So, and then finally, let's plug in 80. And so now I'm going to put in 80. I picked those 60 and 80 randomly, or arbitrarily, just to pick a couple of them. So 80, it predicts 69.26. So 69 is there. So 69.26 looks like it'd be a little bit bigger. Whoops, sorry about that. There we go, 69.26. And then, and then a straight enough line connecting them You don't have to have a ruler for the AP test. I'm gonna double check my work because there's more points that are below than are above, but I'm guessing like the outliers here are kind of doing it, and I'm drawing it as best I can. It's not perfect. So 35.1 plus 4.427, yep. And I plugged in 60, yep. And I plugged in 80, yep. And I got less than 61, yep. And I got more than 69, yep. Okay, looks good to me. All right. And so I drew it, and so now, like for question A, you just had to draw it, but they might want to see a little work. They always expect to see work on these things. So just for A, I'm just going to show that y hat of 60, using like function notation, equals 35.1 plus 0.427 times 60, which is 60.72. And so I'm showing my work on it, and y hat of 80. I've shown it once, so they know how I did it, and so that shows them how I got that line. Okay? Next one. One father's height was 67 and his daughter's height was 61. Circle that point. So the father was 67 and the daughter was 61. There they are. Okay? That represents this pair, and draw the segment on the scatter plot that corresponds to the residual for it. So this forces people to actually understand the ideas. So the segment would be like that. And you might say, well, duh, that's a really easy one. But some people just memorize the formula for residuals and they don't understand it's the vertical distance. Sorry that my head is in the middle of the writing there. And so this is just check and make sure you've got the idea that it's the vertical distance. Cool. And so I drew the segment, give a numerical value for the residual, okay? So the residual equals the actual minus the predicted, AP, which is, actual is, she's actually 61 minus, and the predicted, I have to plug in 61 to the formula. So y hat of 61 equals, so now I can, wait, not of 61, of 67. I just noticed that number showing up twice, and so I was kind of watching out for that. All right, so this is when the father's 67. Yep. All right, 67, put that in. I got 63.7. 63.7. Does it look like about 63.7? My line's not perfect, so it looks like I'm more around 64, but I'm just guessing I didn't draw the line that well, and I'm not right on the values, so good enough. And so it's 61 minus 63.7, which equals negative 2.7. And let's put units in there. That would be inches, because she is 2.7 inches shorter than the least squares line predicts. It doesn't say to interpret anything, so I'm not going to write that out. But if they said interpret this value, then you'd say something like that. Suppose 8471 is added to the data set. I wasn't kidding about these being common questions. So 84, wow, okay, it's going by twos. 8471. So yeah, right there. This is just what we were talking about. I'll let you know I didn't pick this problem ahead of time. I just grabbed 2 free response questions that I thought that didn't tie in other stuff from other chapters. So okay, running out of time. I got a minute left. Okay, would the slope of the least squares regression line increase, decrease, or remain about the same? The slope would remain about the same. The point is already on the least squares regression line. I might think about adding more to that, but because of my time, I'm not going to add more because I have to finish in 40 seconds. Would the correlation increase, decrease, or remain about the same? So the correlation is already positive, and it would get even stronger with that point. High leverage, right on the line, the correlation would be stronger, and so therefore the correlation would increase. The correlation would increase because the point is on the line already, and I'm going to be out of time, and has high leverage.